Hi everybody, welcome to my talk today for Lincoln Science Week. So I am a forensic anthropologist and I would like you to be a little bit interactive. So if anybody has any idea what that is, big clue might be in the background here, can you type it into the chat? And feel free to put anything in the chat that you want to ask me throughout this talk. And I think that's just appearing in the chat on the side there. So, nothing coming up yet. So I hope there are some people out there. So behind me is a skeleton, okay, and some skulls as well. And I use these at the University of Lincoln to teach students in the School of Life Sciences and in the School of Chemistry who are on various programs, including forensic science. And one of the modules that we teach is forensic anthropology. So forensic anthropology is the analysis of human remains for a forensic investigation. So I have in my past worked in many contexts throughout the world, including in Latin America, where I've worked on mass graves. I've worked in sort of war crimes and crimes against humanity type projects. And currently in the UK, I work with UK police forces on many investigations that include human remains. Now, you might be asking yourself, well, what's the difference between a pathologist and an anthropologist? So a pathologist will look at the body when there's soft tissue, so when everything is intact, and they can get a clear idea of cause of death by doing an autopsy or a postmortem. An anthropologist is called in when we may have a skeleton, like is in the background, and also if there is decomposing remains. Now, I would warn you in this talk that we are going to see some images of human remains. So I'd like to warn you about that. So if you don't feel comfortable looking at that, this will be in the latter part of the presentation, because I'm going to show you a couple of my cases and things that I've been working on. Okay, so the first thing we need to have a look at is thinking about the, we've defined what forensic anthropology is. Okay, so it's the analysis of human remains in a forensic context. So what do we need to know? Well, the first thing we need to know when we find human remains is who that person is. And the way we do that is by estimating a biological profile, which includes sex, age, ancestry, and stature. Now, we also have a look at individuating features, which may be something like a pathology that a person has or an ante-mortem trauma. Okay. Now, the second thing that we do is that we look at a skeletal injury, and we do this because we are wanting to assist the pathologist with cause of death. It's not that we actually will define cause of death, but we will describe and interpret skeletal injury that will give the pathologist, help the pathologist to come to their own findings as to the cause of death. And another thing that we do is post-mortem interval. So we will look at the remains, and sometimes in many cases we've had remains that have been many years lying somewhere, usually in a wooded environment, in an outdoor environment. I've had ones in caves. Sometimes they are in situations where they're inside buildings. Okay, so especially abandoned buildings. So these are the types of things that we can assist the police with. So throughout my sort of talk, we're going to get to know some of those things a bit better. So the first thing I'm going to do is talk you through the human skeleton and what particular aspects of it we use for cause of death. So I'm going to, for identification. So I'm going to share an app with you, and please type in anything if you have any questions so I can see. Here we have a skeleton, so I hope you can see that. Now we can see all the different bones of the skeleton. So does anybody know how many bones there are in the human skeleton? So just looking at the chat, if you think you want to take a guess and put into the chat how many bones there are in the human skeleton, there are 206. Okay, so did you know that? Did you know that there were 206 bones in the human skeleton? Now we can do some cool things with this app, and we can look at the cranium or the skull. So the skull is the cranium, which is the head bit there. Okay, the top of the head up to the upper teeth, and then the mandible is the lower jaw, and that makes up the skull. So we can have a look around there, we can turn it around and see. And the other thing we can do with this is that we can look at and explode the cranium, which shows you exactly how many bones are in there. So if you can think about, there's a lot of bones in there. You can see some of them are paired bones. So these two bones here are the parietal bones on the top of your head and the side of your head. And there are actually 22 bones there, plus 6 ear bones that we can see in the human skull. So there's quite a lot there. And they are joined together by something called sutures. Okay, and these are important when we come to looking at age estimation, which I shall go on to in a bit. So if we just go back to the skeleton again, and I'll get my pen. So thinking about which areas we would like to look at for sex estimation. Okay, so again, we've got the skull and the pelvis. So these are the two areas that we mainly look at for sex estimation. So we're looking at morphological features of the skull. We can also measure the skull in different, using different landmarks to carry out some statistical software to see what the sex is. And also with the pelvis, we can look at morphological, so that means the shape of characteristics in the pelvis. We can also use long bones, okay, and sometimes joints, because males and females have different sizes. Okay, so the females will be smaller, they're more gracile, which means fine bone, the males that are more robust. So these are the kind of areas that we use for sex estimation. And if we change the colour of my pen, and for age estimation, the parts of the skeleton that we're going to use for age estimation, again, we can use the skull, so you can see how the skull now is becoming quite useful. We can also look at teeth, okay? The teeth are useful. And we also want to have a look at this bone here. So does anybody know what bone this is called? It's the collarbone in sort of everyday language, but does anybody know what that bone is called in anatomically? It is this clavicle bone. Okay, so we look at the clavicle. The spine is also useful for age estimation, because as a person gets older, okay, they will develop something called osteophytes, and that is because the spine literally gets worn down. And as it gets worn down, the bone sort of comes into conflict with each other, and it produces little bone spurs, which we can then see as to whether that person is older or not. So it can kind of give you a clue as to whether this is a younger adult or an older adult. And then we look at various parts of the pelvis. So we look at this part here, which is the pubic symphysis. Okay, now the pubic symphysis is where these two pubic bones meet at the front. And again, this is an area that degenerates over time. And this is, we can look at different phases as to how this has degenerated. And there's been some methods developed where we can compare the morphology of this area to see what age bracket this person would fit into. And the same goes for this area here, which is the sacroiliac joint. And the sacroiliac joint is where the sacrum joins onto the ilium. And again, that's an area we can see for age estimation. Okay, so, and one of the other things we can look at is the rib, so the sternal end of the rib, and that's the same thing. So when we're trying to age an adult, we are looking at how that person's bones have developed. And that's why I looked at the clavicle, because the clavicle is the last bone to develop, and that will be probably fully fused by around the early 30s to late 20s within an adult. And then once that's happened, then bones start to deteriorate, and sort of that means wear and tear, and we can use that wear and tear to then put people into phases. Okay, so that is age estimation. And the other part of the biological profile that is important is knowing what sort of population group that person has come from. So we call that ancestry. So it's kind of geographical origin. And in sort of basic terms, we can divide people into 3 continental groups. So people from Africa, people from Europe, and people from Asia. And we do that, we look at characteristics within the facial skeleton. So the facial skeleton, especially kind of like the shape of the nose, okay, all around the nose, will give us a clue. And we're looking at things like frequencies of characteristics in certain population groups. So it's not an exact science, but it gives us a good clue. We can also measure the skull like we did as well for a sex estimation, and put that data into some software which will tell us the group that this person's skull is most closest to. So that's important when you've got a missing person and you have an idea of who the remains may belong to, and it might be a female, it could be an Asian female who's fairly young. So if you find the remains and they're a male and they're from Europe, then you can rule out that person straight away. Okay, so, and the last thing that we do with biological profile is looking at stature. Okay, so if I change my color again, now with stature, we want to measure long bones. So this is the femur, okay? So this is your thigh bone there that I've just outlined in pink. And that bone there is good for measuring. So this is a good ratio to the height of living height, we call that, or living stature. So we can measure this and again use a regression formula to estimate the stature of the person. We can also, if we have all of the bones, which we often don't have in forensic work because we don't recover everything, especially if it's been a long time where those remains have lain, we can take skeletal height. Okay, so we can measure all the skull, all the vertebra, the first segment of the sacrum, and then the long bones, and then including the ankle bones as well, which is the talus and calcaneus. So that is what we do for biological profile. So does anybody have any questions about biological profile? And I will go back to the skeleton. Just clear that. Okay, no questions so far. So if we can look at these a little bit closer, and I can show you some of the features of the skull. So what we're looking at here is a male skeleton, and some of the parts that we look at with the male skeleton is the mastoid process here. So the mastoid process, the size of that bone there, and it's part of a temporal bone, which is on the size, would indicate whether this is a male or female. And I say indicate because we judge it on a scale from 1 to 5. So it could be really, really small, female, much larger, as this one is, would be male. Okay, so that's one of the features. And if I turn it round as well, we can look at this bumps on the back of the occipital bone. This is occipital bone, the back of the head. Okay, and this you can see here we've got some bumps, and this is where the nuchal muscles insert. Now, males have larger muscles than females, and so they will have larger muscle attachments. And you can see here, and if we turn it round, that we do have some muscle attachments. They're not massively prominent that you would expect on a male, but they are prominent nonetheless. Okay, so and again, one of the other parts that we want to have a look at is the chin. Okay, so the chin is here, and we can see there's a little bump in the middle of the chin. That's called the mental eminence. And again, the size of that will depict whether this is a male or female. So the larger the size, it will be a male. And we're also looking at something called the glabella. Now, if I can just put it in that view, you can see that bump over there, which I sort of call bony eyebrows. Okay, and you can see that this bump just above the eyes, where your eyebrows would be, there. Again, that's called the glabella. It's quite prominent, and that would be a male. Women, females have straighter foreheads. Okay, so and again, if I look at it in this view, we can see the ridge there in the eye orbit. So this is where the eye would be, and along that margin there, it was quite blunt in this skeleton. So if I make it a little bit bigger, we can see across here that it's quite blunt. It would be quite sharp in a female. So again, we kind of look at a 5-point scale for that. So I just wanted to go into a little bit of detail about the app and the bones of the skeleton according to how we estimate biological profile. So what we'll do now is we'll move on to a PowerPoint if there aren't any questions, and I'll show you, we'll move on to the next part, which is cause of death and post-mortem interval. So I'm going to stop sharing this screen now and go to a PowerPoint. And you should be able to see that PowerPoint. Okay, so when we are talking about cause of death, as I've said before, a forensic anthropologist does not determine cause of death, but they do help or assist the pathologist by describing and interpreting skeletal injury. So here we have two skulls or crania, because they don't have the mandible with them. So let's have a look at, first of all, at the one on the left-hand side. And on the left-hand side, we can see that this there's a big hole in the top of the head, which is not very good. Now, this is a skull from the University of Lincoln, and it is from the Roman period. So we had this radiocarbon dated, and it is around 2,000 years old. And it was found in the River Witham, close to the university. And so this is our, I like to call him our sort of like famous Roman, whether he was a soldier or whether he was a slave, we don't know. Okay, so we've got a question. So I'm going to come back to that questions when I get on to the next part about PMI. So thinking about trauma then, does anybody could have a guess as to what might have caused this hole in the top of this person's skull? So we've got a big a hit to the head. Yeah, you're absolutely right. So we have different types of trauma. And we have, when somebody's hit on the head, they can be hit on the head with a blunt object, or they can be hit on the head with a sharp object. So it's the same kind of action, and we call this different: blunt force trauma and sharp force trauma. Now this, if you can have a look at these sides here, now bear in mind that this skull is 2,000 years old, and it has been found, it's been in the river mud for a very long time. We can see we've got some pretty straight margins down here. Okay, and for me, when I was working in Guatemala, and I excavated many victims of the civil war there, and one of the main causes of death was machete, so killing people over the head with a machete. So this is quite similar, and we know this because we've got sharp edges, we've got straight lines, and we can almost see, of course, over the 2,000 years, this has been eroded. So we probably haven't got as it was when it was first done, but we can see these straight edges. So this would be, he possibly was hit with something back in those times, would be something equivalent of a machete, would maybe be a sword or something like that. And we can see there are several cuts because we can see the different directions that these cuts go into. So there's probably about 4 or 5 cuts into this skull. So this is what happens with a sword or a machete, or if somebody's hit over the head with a sharp object with quite a chopping action, we call this. Okay, so that's one type of trauma. So what an anthropologist would do is they would describe these fractures, and they would describe exactly where it is, and they would come up with what its compatibility is, and in this case it would be sharp blunt trauma. And then they would maybe do some interpretation, which would be how many cuts, and could you actually sequence it. Now if we move to the image on the right hand side, again we can see this is a crania, and we can see a hole just behind the temporal bone, just above the mastoid process. Remember, we looked at the mastoid process, and this is from a case of mine in Afghanistan, because I've done some mass grave work again in Afghanistan. And does anybody know or think what may have caused this small defect, this circular little defect in the side of this person's head? Okay, so it's a very small hole. So this is a gunshot wound. Okay, and we can see a little fracture that is, these are called radiating fractures, and this little fracture is radiating away from the defect. So that would be the entrance wound of a gunshot wound. It'd be quite a small caliber weapon because it is very small. The hole is very small, and it hasn't caused a lot of fracturing. Now, I've worked a lot in my cases in Guatemala with military rifles, and they would cause a lot more damage than this. This is a small handgun, but we can see one little fracture that's running down from that entrance wound there. I don't think there was an exit on this, so the bullet would still be inside there. So one of the things we'd want to do, if we got this as a case, would be to take an X-ray before we did anything to see if there is any bullet fragments or any bullet inside the skull still. Okay, so that's a little bit about trauma. Now we move on to post-mortem interval. And Esther, you asked me if most bodies are found outside. Do woodland animals or other species affect what you can find out about them? Okay, so in that case, do you mean what animals tend to do if you've got, say, some remains in a wooded environment? Animals tend to scavenge and scatter those remains. So we have to do a big search to try and recover as much of the skeleton as we possibly can, because animals are known to take them quite far sometimes. And in those cases, it's not often that we would recover all of the skeleton. Okay, so they do play a big part in what we call taphonomy. Now, taphonomy is all the different processes that happen to an individual after they have died. And in this case, on the left-hand side here, we can see something very distinctive here. We can see part of the mandible is is much paler colour than the rest of it. The rest of it is kind of like a browny colour, and then we have the piece of mandible here that's quite white. Now, again, this is a case from Afghanistan, and what this has told us is that because these are two different colours, they were fractured at the time of this person's death. So because they came apart, and we can see that because we can see some very distinct straight edge fractures in the mandible here. So this actually was a gunshot wound again. And as that grave was disturbed over time, they were buried, but some of these parts that had already been fractured had made their way to the surface, and they became bleached by the sun. And then that's quite important. And in this case, it was because the remains had been disturbed. The grave had been disturbed because of the person's building work that had been going on, which is often the case in Afghanistan. People were buying a lot of land and building houses, and they were finding lots of graves. So that gives you kind of a good idea of what happens when we've got remains on the surface. Okay, so they often get bleached by the sun, and then they can also get scavenged by animals, and they would cause maybe some chewing of these parts here. This is a condyle here because they like to get, especially canids like to get their teeth around that, and the rest of it was still buried, and that hence the brown colour staining, which is from the decomposition process. And we can see on the right hand side that we have a cranium. So from the university, but it's a very dark colour. It's a bit like the first one we saw with the trauma, and this is because this is a Neolithic skull that was found in the River Witham again, down near Fiskerton, and it was within the river mud. And because that creates an anaerobic environment, it means it's different enzymes that are decomposing, and it stains it very, very dark. Okay, so there's a lack of oxygen there. So this is sort of like a different colour to this one here. So again, looking at the colour of the skull, looking at things like animal predation, we can kind of try to work out what has happened to those remains since that person died. And one of the other main sort of parts of my job as a forensic anthropologist is dealing with burnt remains. And burnt remains, what we need to do here in this case, and this is one of my cases from Guatemala, is we need to go through all of those procedures that we did if we just had a whole skeleton, which is try to work out biological profiles, so sex, age, stature, and ancestry, and also try to identify that person, see if there's any individuating characteristics and any trauma we can see. Now, it's amazing how much information we can still get from remains that have been burnt like this. So one of the things that we would do would be to sort out everything and so all of these pieces here are pieces of skull at the top here. We've got the spine, we've got some rib fragments, and on one of those rib fragments we might have a sternal lens, so we may be able to do some aging. We've got some vertebra here because these are pretty much protected by soft tissue, so we can see if there are any osteophytes on here, again looking at that person's spine to get an idea of age. We've got some pelvis here, so we could look at whether this is a female or a male. We've got the femoral head there, so we may be able to measure that to get an idea of male or female. And again, looking at the different colours of the burning as well, we may be able to work out how this person was burnt and what actually happened. So this is, kind of like bread and butter of forensic anthropologists' work would be dealing with burnt remains, because this is obviously something that we can do because there's no soft tissue on these cases. You can see this here is just calcined bone, which is this very grey bone. We can sort it out. And one of the other really important things to look at in a fire is how many people are represented in that assemblage. So in this case, it is one person, but this was a female that was buried in a grave with her children. So again, being able to separate the adult remains from the juvenile remains is really important to get minimum number of individuals. So what we do with minimum number of individuals is we'll take one particular piece of the skeleton that has been repeated, and we'll be able to say, well, like say, for example, here we've got the right femoral head. If we have 4 of those, then we know that there would be at least 4 individuals in that assemblage of remains. Okay, so that's burning. Thank you for listening for this talk. If you have any questions, feel free now to type them in the chat. I'll stop sharing this now. I'm back here. Doesn't look like there are any questions, so I shall say goodbye, and thank you very much for listening. Bye-bye.